Alright everyone, so here's our first day with the new system. So remember, you got today's homework here, and then the assigned part that you're going to turn in on Google Classroom is the presentation problem number 46. Give me a chance to, one, turn these notes into an assignment, so it's going to show up on your to-do list, which I think will be helpful for a lot of you. And then it can also gives me an opportunity to look at your work and maybe point out some issues if I see any. So if you haven't already, please get your notes ready, print them out, or set them up in your notebook so that we can get started. Let's begin with some definitions here. We've got sequence and recursive notation. Now, a sequence is a function whose domain is the natural numbers. So natural numbers are like 1, 2, 3, 4, etc., but you can't plug in like 2.5 or -7. And usually you just see it as a list of numbers. So you'll see the natural number, it tells you what term it is. So this is like the first term, the second term, all the way out to what's called the nth term. And they're often just written in this order like that. So let's do A here, and then we'll talk about recursive notation since it shows up in B. For part A, it says, write out the first three terms of the sequences. A sub n is equal to -1 to the n over n. So this is what we call our nth term. This is the actual function itself, where n is the variable. You'll notice that that's what's changing in each of these terms. So when we're writing out the first three, what that means is the first one here, a sub 1, this is where n equals 1. And then a sub 2 and a sub 3, those are your first three terms. We plug them into the formula. So the first one, -1 to the n is 1 over n, which also is 1 again. -1 squared over 2, since we're replacing here the variable in both the numerator and denominator. Then -1 to the third over 3. And of course, for our final answer, we want to simplify that to -1, +1/2, and -1/3, 1 over 3. These are the first three terms of this series, or sequence, excuse me. I'm going to reverse those, and I will try my best not to. The sequence is when they're just written out in a list. Now here, what you see in part B is what we call recursive notation, where it says a sub n is equal to a sub n minus 1 over 2. And this is recursive because to find the nth term, you use the terms before it. So the n minus 1 term, that's the consecutive one before it. And you just sort of go in order as you work through. So in this case, when we're looking at our A1, A2, A3, we already know the first one, right? This is then -8, which is very convenient. But then the rule says, to find the next term, take the one before it, divide it by 2. So to find A sub 2, you would take A sub 2 minus 1, which is just 1 over 2. And so then we can say, okay, well, this would be -8, plugging in here. And so then A sub 2 is -4, because it's -8 over 2. And then we would divide that again for our third term, because then we just take that divided by 2, and that equals -2, meaning our first three terms are -8, -4, and -2. So recursive is one of those things that's easy to use once you recognize it, but it can be really complicated and weird to look at the first couple times. Sort of like function notation when you were first learning that. Let's keep going. Here, This is one of those creative problem solving ones just so that we can practice this. Write the nth term of this sequence. 3/4, 4/8, 5/16, 6/32, and I've left them unsimplified because it just makes it easier. So what you're doing here is that there's not specifically steps to do. You're going to look for the pattern in this sequence to be able to try to figure out what's happening. So what I notice here is that there's two separate patterns in the numerator and denominator. In the numerator, it goes 3, 4, 5, 6. So that's just a, this is just counting plus 1 each time. And in the denominator, it's powers of 2 because we're going 4, 8, 16, 32. And so then we're just talking about 2 to the something here. So when I write my rule, a sub n, I know that in my counting, this is the n equals 1. This would be then 4 is n equals 2, n equals 3. So I'm going to go with the n value, but since we start at 3, we should say n plus 2, because that gives us 3, 4, 5, 6, etc. In the denominator, we've got powers of 2, but you'll notice that we don't start at 2 to the first, because this is our n equals 1 term. We're not starting there, we're starting at 2 to the second. So I'm going to make the exponent to n plus 1 so that we get to start at 4 and not 2. These problems are kind of like the trickiest ones because there aren't really steps to just tell you to follow and you'll all be able to do it. But if you want to give yourself a little bit of a brain challenge, they are definitely there in the homework. As you can see in the title, this also is talking about series, which are the sum of sequences. And series are always written with this symbol here, which is sigma. And the numbers here will tell you about how to add up the series. Whatever number here is the variable, and then you're going to have a starting number and an ending number. So what that tells us here is, and sorry about the formatting, something happened when I changed computers, is that we're going to have the number we start with, and we're going to start with 1 here and go to 4. So what that means is that we're going to first say, okay, start with the k equals 1 term, plus the k equals 2, k equals 3, k equals 4, and you're going to add them all together, going from 1 to 4, because that's what these two bounds tell us. 1 is the start, 4 is the end, and then k is the variable, which makes sense because the terms are k squared as the formula here. So the k equals 1 term will be 1 squared. K equals 2 is 2 squared. Oh, that should be an addition sign, since it's a series, plus 3 squared plus 4 squared. And from there you can just do the math. 1 plus 4 plus 9 plus 16 is equal to 30 as our final answer. So series, it's mostly addition, just learning about the notation. Let's look at another example just to show you a quick error that some of you will make. Here it says find the sum from k equals 1 to 2. So we're just again looking at k equals 1 plus the k equals 2 term. And you'll notice it says 2kx squared. Because this says k here, that means that's the only variable that's going to change. The x is just going to stay x. So when we're doing 2kx squared, we're just changing that term, so it's 2 times k, which is 1 times x squared. So, and again, you'll notice only the k term changed, plus 2 times 2 for this new k term, x squared, and we're only going from 1 to 2 because that's what our bounds tell us. And again, once we've written out the terms, it's just simplifying. We've got then 2x squared plus 4x squared which simplifies to 6x squared like that. Please let me know if you have any questions or if you're stuck on anything. There's another example in the notes if you're interested, but I don't want this video to get too long. I'll be available by email, on Google Classroom, or on Zoom. So please, please, please let me know if you're stuck or if you have any thoughts about the new assignment system.